Okay, so my name's Brian Holt. We're talking about unintuitive web performance today, which is about Babel and Webpack and things like that. This is kind of an informal talk, so raise your hands. I might nod at you and get back to you, but I'm happy to answer questions when and as you have them. So we're talking about things that that I found unintuitive about web performance. I've done quite a bit of this. Let's get through my bullshit intro / self pat on the back. I currently work at LinkedIn. That's kind of a new thing for me. I've been there for about 3-4 months. I'm probably more well known for working at Netflix. I worked at Netflix for like 2.5 years, which was an adventure. I also worked at Reddit. So I like to say that this is how I help you with your time, and this is how I help detract from your time. So I'm trying to kind of make up for it now with LinkedIn. Reddit was just a crazy experience. You can probably ask me about that sometime over several more beers. I realize that it's a very unpopular thing to say here. As I say, you have a king fat. So I will leave alone the altar of Vlade Divac and Chris Webber, but go John Stockton, Karl Malone. I currently live in San Francisco. I actually don't really give a shit about the Giants. But if you were going to talk shit about Juventus, I will fight you. I lived in Torino for a couple of years, so go Juventus. Okay, so some of you may recognize this tweet. I really actually don't want to talk shit on someone, but this is a real tweet from someone well known that I really just didn't particularly care for. But I also kind of agree with the sentiment. So this is kind of like the fine line that I walk when I'm talking about web performance. Is I don't actually want to be a giant raging asshole about this. And this person, I don't know them, but I would say this is kind of a very pretentious thing to say, despite the fact that I kind of agree with the sentiment. So I don't know how to talk about this stuff and not be an asshole and pretentious and make you feel bad about your jobs. But okay, so I'll read it for you. I only ask that frameworks put warnings on their products when they can't be accessible, e.g. this site best viewed with a high net worth. Yes, you're right, but you're an asshole, right? So I don't really know how to deal with this sentiment, but he's kind of getting at the fact that you can have these super heavy frameworks like React, like Ember, like Angular that really weigh down the client and make it really hard to view on $100 mobile devices. And that's hard, right? That you're kind of precluding entire markets of people just based on your framework choice. And that's really tough. But also, we're doing our best, right? Damn it, we're trying our best. Your company doesn't exist if you don't ship stuff, right? And if you can build it on top of an application layer, some sort of platform, framework, library, whatever the hell you want to call it, then great. Your company's first instinct needs to be to survive, right? It's an organism, right? So if you can't ship stuff, then you don't survive, and frameworks can kind of be the shortcut into doing that. So that's why I hate this. I hate it because it puts a ton of burden on you, but at the same time, it's a burden that we all need to have. So I just have lots of feelings, and I just wanted to share with you all. So thank you. This is my wife, and she's rolling her eyes perpetually as I'm speaking. She just did it again. It's awesome. Okay, so we're going to talk about how to optimize your website. So how to optimize your website in 10 easy steps. If you can't read it, I will read it for you. Number 1 is optimize your images. Number 2 is optimize your images. Number 3 is optimize your images. Number 4, the same. Number 4, subpoint 1 is be sure to optimize your images. Oh, be sure to optimize your, I don't know if I can say the F word, but your effing images. Optimize your images all the way down to number 10, which is everything else we're about to talk about in this presentation. So, by raise of hands, who thinks you should optimize your images in your presentation? Nikki, I need you to raise your hand. Thank you. Okay, so be sure to optimize your images because that is just free performance. You just have zero reasons not to. Anytime you upload images to your website, just optimize your images. Literally, there's a program for Macs, which I'm just seeing a bunch of Macs looking around. Because we live in California and we're all a bunch of assholes. You get to be in my collective group of assholery. That there is a program called Image Optim. Just download it. Just literally drag and drop your images into it. It will make them much smaller and then upload it. Make sure that you still has the rotation meta tag on it if you were relying on that. But beyond that, make sure you optimize your images, because it's literally just free web performance. Like, it's trade-off free, no reason not to do it web performance. So optimize your images. Okay, I'm gonna say it like 7 more times because it's just free web performance. So beyond that, we're gonna go through a couple more just do's of web performance. Okay, so these are just trade-off free web performances. If you're not doing them, you are literally just losing out on free web performance. Optimize your images. Please? Like, that's really all I'm asking here. Like, if anyone optimizes their images after this talk, like, I have won the game, right? Like, that's all I really want from you. Okay. Compress your text responses. And I'm looking at Devin. Because we were not. I'm probably not supposed to say this, but I'm going to say it. So we just found out that the project that Devin and I work on for the past 3 years had not compressed any of our API responses. Like, when I say compress, like, typically when you send down like some sort of text response, whether it's CSS, HTML, CSS, API, JSON responses, anything like that, it gets run through gzip or some sort of compression algorithm, but typically gzip. We found out that none of our API responses for 3 years were being compressed. So it's just being sent down in plain text, unoptimized, uncompressed. So do that. That's all I have to say. It's just do it. Like, there's literally zero reason not to do this. It's free, right? It's for free. Your server can compress things so fast that there's no reason that you would ever not compress something. Unless it's maybe tiny, tiny, tiny. But at that point, it's probably you're like at break-even point. So just do it. Okay. Any questions? No, because they would be bad questions. Just do it. Okay. So this one's maybe a bit harder. This requires maybe some sort of trade-off, but if you can limit the amount of DOM nodes that you're sending down. Now, I'm not saying like 10. I'm saying like, according to Google, it's 1,500, right? So 1,500 is kind of like the amount of DOM nodes you want to start sending down before you start seeing some sort of trade-off, at least inside of Chrome, according to them. Depth can hurt you as well. If you're like 20 or 30 levels deep inside of your DOM tree, that can have some performance trade-offs. I'm going to like say this is not that big of a deal if you're maybe like if you have like 30,000 DOM nodes, maybe have 2 pages, maybe. But this one I guess probably is not necessarily so much a just do, but maybe think about. So just think about. We're going with that. Okay. Maybe do's. AKA you're making some sort of trade-off, so be sure it's the right one. So this is kind of the point. Everything beforehand, if you just like tune out after this, maybe don't. Like, I'm still up here. I came here from San Francisco to talk to you, so maybe don't tune out. But if you were going to, start now. And just do everything beforehand, right? Like, all that's the stuff that you should think about, because this is going to be, we're going to be talking about maybe hundreds of milliseconds, whereas here beforehand, the just do's, we were talking probably about seconds, like whole seconds. If you're not optimizing your images, if you're not doing those sort of just do sorts of things, you're just losing out. Okay. Before I start ranting onward, does anyone have any questions? Yeah, please.
What was that optimized Mac thingy?
Image Optim. Yeah, it's very aptly named. Yeah, it's free as far as I know. Yeah, it's open source and free, and you can just download like a Mac app. I think they have a CLI client. There's 10,000 ways to do it. But yeah, Image Optim, the Mac app, is something that probably most of you should have installed on your computer. Yeah.
Just so people know how much of a no-brainer it is to gzip things.
Yeah.
How much do you actually gain in that compression?
So for our particular website, we gained 1.75 seconds of web performance just by compressing our API responses. Let's see, that would be to time to interactive. So it was free, and we weren't doing it. They weren't doing it. I'm not going to include myself because I just joined the team. Do you have a question?
Yeah.
presentation, is ImageX still like a valuable option?
To be honest, I don't know that much about it. It's constantly changing. They have 10 million ways of compressing things these days. So just do the best one.
ImageX is a paid CDN service.
Oh, yeah.
They're the top-notch
Image
way of doing it, but they
IMGIX, right?
GIS.
Yeah, I worked with them when I was at Reddit. They're really smart people, so I would trust them. Yeah. Oh, just very relaxed. Cool. I'm a relaxing person. That's not true. Okay. Other questions? That's a party foul. Okay, so all these things beforehand, again, just stuff I really want you to do, really the important parts of this. I'm going to imagine most of you are at least doing some or most of what I've talked about, right? So that's why I kind of built this presentation, is I kind of got frustrated with these framework authors, with these armchair pundits of web performance saying like, definitely always do this, without exception, this will be good for your website. Are we okay over there? Did we spill, or is that oh, okay, cool. It's concrete, it'll come out. So yeah, I got really sick of hearing this, you should definitely always server-side render your website, right? Or things of this nature where you're telling people definitely always make this trade-off, despite this fact that this trade-off could be drastically really bad for your website. So I wanted to kind of talk about these things hey, when you choose to do something like X, you're making a giant trade-off and you should measure it, which is exactly what Devin's going to talk about. So I'm not going to tell you how to measure it, but I will talk about the metrics. Okay, so let's talk about server-side rendering for a second, right? So what server-side rendering, which I'm at SSR, I come from the React background, so that's render to string, but if you come from an Ember background, you have fast boot and all these different kind of things. It's not always a slam dunk win. You might introduce this thing that introduces a lot of code complexity to your website, but you actually might be seeing performance losses. But you might get these warm fuzzy feelings I'm doing good for my website. I introduced this really cool piece of technology that's really new and shiny, but in reality, for your particular application of it, it might go against what your goals are. It might go against what your architecture is. So you need to measure this to make sure that what you're going for is actually what you want. I'm basing a lot of this talk inspiration from Adi Osmani. Again, it's probably someone that you all probably know as well. If not, you should definitely go read his work because he's way better about this stuff than I am. So server-side rendering, this is coming, I'm going to just disclaim this, that this is mostly coming from a React perspective because that's what I have a lot of experience in, but it's probably not too far off from most other frameworks and or just vanilla JavaScript for that matter. So things that you're going to really see are these first three. You're going to see first paint wins, right? Because you're going to load a bunch of HTML right away. So, okay, let's go back. Let's talk about what server-side rendering actually is, right? So if I'm building we're going to take React because I know that. You send down just a bare bones amount of HTML. You send down a JavaScript layer. The JavaScript layer pulls in a bunch of data. Maybe it's from the API. Maybe it's hydrated from your HTML document. You render out some sort of markup, and then it just spits it out to the DOM, right? That's kind of like the MVP of this. So you can build it so it's totally JavaScript rendered, and that's awesome, right? Feel good about that definition so far, right? So with server-side rendering, you have some sort of server layer. 99% of the time that's going to be a node because it has to be able to execute JavaScript in some fashion, but I've seen it done in Rhino and Nashorn and some other really less fun ways to do it, if we're being honest. It renders out some sort of complete markup, and then we send down the HTML all together, and then the JavaScript layer, instead of rendering out the first time some sort of bit of markup, it bootstraps itself and takes over the existing markup. Cool? Does that make sense? Okay. So that's server-side rendering. What kind of wins are we seeing there? Well, we definitely see first paint wins, right? Because it sends down complete markup. The user immediately sees stuff, right? It sees HTML, it sees CSS, it sees all this complete markup. So first paint, big win there. First meaningful paint, also a big win there. So let's talk about the difference between those metrics. First paint is just anything the user sees, right? Usually when you're doing some sort of bootstrapping in your application, for like the big psychology win, you want users to see something right away. It may not be actually super meaningful, but you want them to see something for them to think, cool, this is starting to like take shape in front of my eyes, and then their brain starts turning on what they actually want to do with the website. It's, you know, proven huge wins, especially like in the e-commerce space, so that people can actually make decisions of what they want to do, despite the fact that not everything there is there right away. First meaningful paint is going to be something like, now they can see actual real products that they actually want to buy, those sorts of things. So questions about the difference between those two? First paint is just like anything, right? First meaningful paint, so what's that?
Be like a loading spinner.
Yeah, exactly. Yeah, loading spinner would be a good one. SEO to me is like witchcraft and black magic. Like you have to like sacrifice goats and stuff like that, as far as I know, to actually get SEO wins really well. But according to a bunch of studies, like if you have it markup immediately instead of waiting for JavaScript, SEO is still winning despite the fact that Google executes JavaScript, which I don't really know what that means, but supposedly they do. Okay. So let's talk about the downsides of server-side rendering, because a lot of times people talk about SSR and they don't really talk about the downsides, right? Well, if you're sending down, okay, so you have, first of all, you have to render everything on the server, which I think I have here, first byte, which is the last one right there. Your first byte time, almost by definition, has to be lower, right? Because you have to do some sort of server-side rendering first and then spit out markup. So that means by the time the user receives their first byte, it has to be longer, because before you weren't doing any server-side rendering, and now you are, so you have to take some time to do server-side rendering, right? So by the time the user receives that first byte, it's going to be that much longer, whatever it takes, right? Sometimes it can be pretty fast, like, for example, preact server-side render to string, not too bad. Reacts, especially if you have like difficult reconciliation, can take a while, right? So first byte's going to be slower, which then in turn is going to lead to, by the time that you can get to first interactive, right, is going to be longer as well. And so first interactive is when the user can actually click on something and it executes JavaScript and does something, right? So that time is going to be lower. So that's not a win there. And you need to be asking yourself, what actually am I optimizing for? Do I care for first paints? Usually in e-commerce websites, that's something you want to optimize for. You want the user to think that your website's really zippy, right? Because all the research that I've seen says that first paint is the number to optimize for e-commerce. But if you're doing something like developer tools, or maybe that's like, you know, showing graphs for a developer tool, I don't know what it is. But usually first interactive is probably going to be something more optimized for. So you need to ask questions about, what am I optimizing for? You're going to see this code complexity thumbs down a lot, because all of these things make your code more complicated, right? If you have to do server-side rendering, there's a bunch of constraints to do. Like you can't refer to window because there's no window in Node, or Nashorn or Rhyhorn or whatever. Rhyhorn, that's a Pokemon. Okay. Consistently interactive, that means like that's by the time that I've rendered everything out and now the thread is idle. That time goes down. Bundle size is going to go up because you have a bunch of stuff to deal with, like rendering your stuff out to a DOM and taking over. That takes code to do that, all that kind of stuff. So point here, server-side rendering, not a slam dunk. You need to figure out what you're doing. Okay. Questions about SSR?
One thing on that, like on the previous slide, you said that first interaction, first interactive. So you said that if you go with the server-side rendering, it will be slow as compared to the client-side rendering.
Yeah, almost definitely, right?
But how come, like, because if
Okay.
I'll try to understand, because for me,
Sure. So, okay. Like a server request comes in, if it's a client side, all they do is you flush your basic HTML out, they download the new JavaScript, the JavaScript bootstraps, renders out, and then the user can start interacting with it, right? That's the point that they're first interactive.
but the bootstrapping will take time.
It takes time, and then your first byte is also slower, right? Whereas if you're not server-side rendering, your first byte's going to be faster, right? Almost definitely. Almost by definition, it has to be.
So when you
server-side render, you have to do all the work that the client is doing for every request on the server.
Yep.
So if you take 100 milliseconds to render on the client, you probably take close to 100 milliseconds to render on the server ahead of time. So you're waiting 100 milliseconds before the client can actually do the work that it needs to do.
You're almost doubling the work, right?
But the thing is, if I understand the server-side rendering, which means that the page is getting created, that the HTML page is created, and we are passing that information, isn't it? Like, so it should be faster as compared to like, because rendering is done, the DOM display is already done, like, and just it's waiting fast to the client.
Yeah, you're making, you may be making the fundamental assumption that, I'm going to talk about React, but Eric can also talk to Ember here, that, okay, I do the server-side rendering, I spit out a full application, then I send down the JavaScript. It's also going to do that full rendering all over again and make sure that what I have and what's there match each other, and then it's going to take over what DOM exists there and start, you know, introducing all the DOM listeners and all that kind of stuff. So you're, again, almost doubling the work. That the rendering cycle is happening both on the server and then on client, and that it's just slower.
So it means that we are doing the rendering at the server side as well as we are doing at the client side?
Yep. Is that, I assume that happens in Fastboot too.
Yeah, I mean, if you go back to the other slide, the point is you get a faster paint, but that doesn't mean when the user tries to click a button that they can click it immediately. They have to wait for the JavaScript to load and for everything. So similar to like if you have an iPhone, you switch apps, and the app is like doesn't respond until it like fully boots because it just shows a screenshot of where it was before. That's essentially what's happening with server-side rendering. You're showing the DOM as rendered by the server, but then the app needs to boot up for it to actually become interactive, and that's why first interactive gets slower.
Yep, that's a great example. Make sense? Yeah, measure it, right? Like more than anything, that's what I'm inviting you to do, is measure what you're doing, make sure you're winning on what you intend to win on. This is what I've observed, and I didn't link the article in here. I should really link that Adi Osmani article in here. But he did a whole case study with a company called Tribo in India, and it's absolutely fascinating, and he found similar things to what I found, is that it really slowed down time to interactive. Cool. Bless you. Code splitting. So we're talking about specifically route-based code splitting, which I imagine, you know, I'm making a great, huge jump here. It's what I'm familiar with, and therefore I'm extrapolating that it's what you are familiar with, right? What could go wrong with that reasoning? Okay, so route-based code splitting is that I load my home page, and I don't load any of my other pages. And then when I click on the About page, it pulls in a whole new bundle of JavaScript. It then bootstraps that up, and now I have the About page. So that means when I load the home page, I am not loading the About page at the same time. Again, we're kind of making the assumption here that you're doing a single page application, but that's where we're going with this. This is something that Webpack has kind of built into it. If you use the require.ensure / the import syntax, which you should be using the import syntax now. But yeah, that's what route-based code splitting is that I load my home page, it just pulls in the code for the home page, it doesn't load anything else. First paint, I put a question mark because it really depends on your implementation. So again, referring to Adi Osmani's article, he said, I believe that they saw about the same in their first paint. So it was kind of a wash on that, because the problem is particularly with React, is you load some sort of like bootstrapping bundle, and then after that it makes another request from the JavaScript layer to load your whatever route you're on. React, to the point of 16, previous to 16, did not really have a good hydration story. It does now, or at least they're starting with it. But in any case, they didn't really have a good way to load that second bundle initially, especially with server-side rendering. So first paint, question mark, it could really go either way, and something you really need to measure. But it's not a slam dunk in either direction. It's not really bad, it's not really good. It's probably going to be about a wash, again with the first meaningful paint. But code complexity, again, I told you you're going to see this a lot. Introducing code splitting just makes things more complicated, right? If you can create these like very simple, very flat route configurations, it's very easy to go in there and say, cool, I go to this page, it loads this component which does this thing, right? It's very easy to kind of like visually follow along that code when you have to go back and debug it later or add more things later. When you start introducing things like code splitting, you have to say, whenever someone clicks on this link, it goes to this configuration, which then has to load this component, which has to show this loading component, which then redirects and loads this route, right? So it just adds like 4 more layers of indirection. Now, maybe some frameworks handle that better, but when you're using Webpack and React Router, not particularly. So, but particularly with subsequent loads, the first interactives are going to be really fast. And you can actually even really start cheating on this. So if I load my home page and it gets just the bare minimum amount of code to load my home page, if you're using something like a service worker, you can have your service worker go out and grab the rest of your routes kind of in the background. And so when the user actually goes to use those routes, it's already loaded. It seems like it's already loaded. So you have like no wait time. So there can be some big wins there, but it comes at the cost of a lot of code complexity. And it's something I really, really invite you to think about. Route-based code splitting is not necessarily like the end-all be-all, despite the fact that we love to bullshit about this on Twitter. I do. It's not necessarily a slam dunk. That's cool. That's probably not what I meant to have on the slide. But overall bundle size actually is kind of a thumbs down because you end up with a bunch of code that handles route splitting, right? I don't know how much that is. I think it's only a couple of kilobytes, but at the same time, it's like death of a thousand cuts. If you have a couple kilobytes to handle all these things, you're going to end up adding like 20 to 30 to 50 kilobytes just handling web performance, right? And that in and of itself might sink the boat, especially if you only have like a 20 to 30 kilobyte application, which you shouldn't route split at that point, right? So yeah, these are all questions you really need to ask yourself. HTML streaming. For the most part, I'm going to say this one's, for the most part, a win, right? So let's just have a brief aside on what HTML2 is, or sorry, HTTP2 is. So instead of HTTP1, where you have like concatenation's a good idea, and you have one connection for one file, and you fan out all these requests, and you get back all these things. That's kind of the thing that we're used to. With HTTP2, you open basically, you can think of it as like one giant pipe, and all of your things come through the same pipe, right? So things like concatenation become less useful because you cannot multiplex. It's one of those asshole words that we just kind of use. You can't multiplex the request. You can't request multiple things all at the same time. So what's really cool about that is you can have these long-running HTTP requests that I immediately flesh out to you like the head of my HTML document has all of my CSS and JavaScript that I need you to request. Your browser starts requesting all of those things, which go into the same pipeline. And then while in the background, I'm hurrying in the server-side rendering while this has already been flushed out. It's kind of a cool idea, if you ask me. Something that LinkedIn's doing. It's something that gave us quite a bit of perf gains. I'm not going to say for free because it came at the cost of some other things. It's a trade-off, right? But HTML streaming, it's a cool idea. It's something that I know for a fact that React is working on, because right now with React, you don't really have the idea of like partially rendering your HTML application. It's kind of all or nothing. You have one function call that gives you back the whole thing, right? So yeah, it's a trade-off to make. Code complexity, again, as always, it makes things more complicated if you're trying to do things like this, because at that point you kind of have to wonder, okay, I'm rendering part of my application but not all of it, or I'm fleshing out some of the DOM, I'm not fleshing out all of it. What has been fleshed? What has not been fleshed? What can I refer to? What can I refer to? It creates debugging problems for you. But your first byte time, I guarantee you, is going to go way up, right? Because someone's going to make a request to your website, you immediately say, cool, here's the head to my HTML document, and they can immediately start requesting CSS, HTML, prefetch, preload, all those kind of things that you want to do. Inline critical path CSS. This is another one people kind of talk about as like, this is always a slam dunk win. And it's not. your first paint is obviously going to go up. So it's inline CSS, like critical path stuff, is that you pull out all of your CSS, all of your JS, all of your HTML that is critical to like the quote unquote above the fold. I feel like I'm saying a lot of air quotes here. Okay, above the fold sorts of things, so that users can immediately see something, right? This is going to be a big first paint win because you've pulled out just the bare minimum so that everything can appear as fast as possible. Normally this is a good thing, but again, it does come at the cost of something else, right? First of all, let's just talk about code complexity again. You now have to have basically first and second class citizens in your CSS and your HTML and your JS, right? You have to consider like, for every piece of code you write, is this critical path, right? Am I affecting something above the fold, right? Because if something loads and then something totally different loads later, you've just totally blown away. You've actually made it worse, right? And yeah, so don't do that. So code complexity, I would say when you're doing things like inline critical path CSS, goes way up because you have basically two classes of things to consider. Your first interactive, again, is probably going to go down because you're loading something first, doing something with it, and then loading something different later, and that just comes at a cost. That you have an initial load and a secondary load. So it depends, right? This can also maybe be a wash at best. And then your bundle size is also going to go up as well, which, like, it's a down thumbs because it's bad, but it's going up. I don't know. You get my point. Maybe you don't. I don't get my point. But suffice to say that you're probably going to have a bunch of code that deals with this kind of like inlining and reconciliation thereof. Service workers, awesome stuff. We all love PWAs, right? I do. I think they're pretty cool. Offline support. Okay, so PWAs, service workers. It's kind of a new specification that you kind of have this like separate thread. We don't really have threads in JavaScript, but you can think of it as a separate thread that's being run kind of in the background, and it can act as like kind of a simple proxy for your application, that my application makes a request to this API server, but my service worker can intercept it and say like, hey, you're asking for this, but I already actually know what it is. I'm going to just immediately hand it back to you. It never actually goes out to the server. The service worker just kind of intercepts it and just hands it back to you. Obviously, that's going to be tremendously faster. Like, even if you're on local area, right? The fact that you don't have to do any sort of handshakes or HTTPS or, you know, request response cycle or anything like that is just real fast. And the awesome part about that is that you can do that offline. So you can have offline support so that people can open your website and never actually have to like talk to a web server anywhere. So offline support, 2 thumbs up, super cool. I guess it's only 1 thumb up. 2 thumbs up. Subsequent loads, obviously, like once you've requested something, you can say, your service worker can say, cool, you requested this, I'm going to go get it from the server. Now that the server's come back with it, now I've seen it, I'm going to store that locally and not request it again. So subsequent loads are going to be really, really fast. So if I come back to your website, you know, 3 days later, the cache is still good. I can pull from it and not have to make any requests. It's going to be really fast. Code complexity. Has anyone in here debugged a service worker before? Yep. I see sadness in your eyes. So it's hard. It's painful. You're going to like pull your hair out. Anyone that's had to deal with service workers before has like, why is this not changing? I changed this on the server. I don't understand this. And then you realize like, oh, holy shit, it's the service worker, right? Yeah. So me too. It's the worst. And you just like want to slap yourself in the face. But first loads typically are not going to see a huge amount of change with service workers, or at least very trivial amounts, maybe in the downward direction. You have a little bit of code to like register your service worker, but that's going to be on the order of bytes. So it's not going to really help you on your first load. It's going to help you on subsequent loads. Skeleton screens. So this is probably big wins that I don't think enough of us take advantage of. That I load my first page and I see something like this, right? I don't have to make any API requests to get it. It's just kind of like, it's kind of a design tactic to make people think like, oh, okay, so I'm going to be looking at hotels in Mumbai and it's going to have pictures here and text over there, and then kind of as the responses roll in, you can kind of, put those in. Even better if you can kind of combine HTML streaming with something like YAML. JSON sometimes is not the best with HTML streaming, that's why I don't necessarily say that. But skeleton screens can be a huge design win, something that you probably should talk about with your designer and say, like, maybe we can think about this. This is kind of a way for like a perceptual win for loading. So first byte's going to be fast because it means that you don't have to pair all of your data with the first load. So you don't have to request that from your backend services. Your first paint's going to be a win because that's going to pare down your bundle size, and you don't have to make any API requests on your first load. Your first interactive is going to go up. First interactive for everything else besides the actual data being loaded can possibly go up, like if they need to click on a menu or something like that. And your first load is going to go up because you're not including all of your data. I don't know what I meant with first load. So yeah, I don't know. Ignore that one. Code complexity. It depends on how you want to think about this, but if you're doing things like server-side rendering, like you don't have any idea of like hydration that you need to necessarily worry about. When I say hydration, that means like I used some bit of data to server-side render, so I insert that into the server-side rendering, and then I also have to load it on the client, so the client can also hydrate. It's another one of those stupid words. I don't know where it came from, but I don't think it's very descriptive, but that's what people call it, so I'm using it. This became Brian ranting at people very, very quickly. So hydration doesn't necessarily have to happen. You can just load the skeleton screens and load that from the API. That can reduce code complexity depending on how you do things. So first, useful. I put it down. There's not really a metric for that, but that just basically means that like if you're loading a page to see hotels in Mumbai, and I show you skeleton screens first, it's obviously not super useful at that point, right? So you have to wait a little bit before the screens actually load. Now, the question is it the same amount of time before, like if I show you a skeleton screen, you understand the layout, the design of the screen, and then I show you the hotels later, versus if I just immediately show you the hotels, I don't know when you're actually going to be able to make a decision and actually click on something, but something worth measuring. Yeah, the payload's going to get a little bit bigger because you're going to have like some sort of logic skeleton screens, but I put a tiny thumbs up because that really shouldn't take very much logic to do something like that. And then SEO is not going to be great because you're going to show skeleton screens, and that's probably what Facebook and Google and blah, blah, blah are going to pick up on. So probably not an SEO win. But again, I think if you sacrifice enough goats and or virgins, then you should be okay. So other techniques to try, lazy loads, images off screen, it's definitely a good one to just throw in there. If you're not showing something to the user, then don't load it at first. Using something like source set, that's getting more and more adopted with modern browsers. So that's going to say some things like, if I'm on desktop, load the large image, but if I'm on iPhone 5, like a small phone, then load the smallest images. And source set is a DOM API to do that with images. Code splitting at the module level, so maybe like don't load the module code until someone's actually clicked on something that shows the module, things to that effect. And atomic CSS, I think this is going to be a bigger one going forward. I'm predicting that because I work with the people that are working on things like that. But that's basically, instead of having this CSS class that has all of these different like properties associated with it, that you're going to write your CSS, it's going to break that into very, very efficient CSS, and that's what your templates are going to load. So you write one thing, and the DOM's actually going to load a different thing. It's coming. It's going to be really cool. I don't really understand much more than that because they're really much smarter than I am. But atomic CSS. You can look at tachyons. That's kind of approaching it. Well, it is it, but it's going to get cooler than that. That's my point. Okay. I've been sufficiently vague about that. Okay. So PRPL, something that you should definitely check out. Notice it's PRPL. Yeah, purpler. I think this is meant to go on the other page. So this is meant to be on this page. I literally wrote these on the car here, right here. So forgive me. Responsively eager loading images. So I probably had a profound point about that. Kind of forgot what it was. So ignore that for a second. PRPL, ignore the last thing. Can I? Yeah, whatever. Push the minimum amount of critical resources. This is from Google. Who maybe knows a thing or two about this. Push the minimum amount of critical resources to render the page, render the initial route, pre-cache everything else, and lazy load the rest of the resources on demand. That is the PRPL way of doing things. If you follow this, it's usually going to be pretty good. You can Google it. There's a whole article on it. It's pretty great. Yeah.
Doesn't that include code complexity or increased code complexity?
Yeah. Oh, definitely. But
this actually falls into one of the categories that you discussed.
yes. No, I mean you're absolutely right. So it's an application that follows PRPL is going to be more complex than the thing that doesn't follow PRPL. So if you're a brand new startup that's fighting to survive and bootstrapped, yeah, don't do PRPL. Just write goddamn web pages that have a little bit of JavaScript on them, right? Don't overcomplicate this. If you worked at LinkedIn and paid way too much to do what you do, then yeah, we should probably do this shit, right? Yeah. So you got to strike that balance, right? This is probably the ideal, you have infinite time and infinite resources, attack the problem this way. Yeah. Find your balance, I guess. Is that sufficiently dodgy?
Yeah.
Yeah, okay, cool.
Dodgy enough that it actually almost contradicts what you were saying earlier, where it's there are no solutions that apply to every case, but then the dodginess kind of makes it okay.
Yeah.
That you did suggest this without that qualification, I guess.
This goes back to where is my slide? It's this one.
Yeah, there we go.
Yeah, do your best, right? You're smart people. You're paid for your opinions. Yeah, it's up to you to research it and figure out what works for your particular use case. PRPL is if you're writing a series of web forms, there's no reason you even need JavaScript in that case, right? You just need forms, with inputs. So.
Well, it depends. You want it to use work offline, then you might need JavaScript.
Yeah, then use a service worker that caches your HTML. So use what's the principle of least power, right? That's a thing, right? Principle of least power. Use the least powerful thing that accomplishes what you want it to do. I think that's a pretty good idea. Cool. Good question, though. Valid point. Anyone else? So if you're not all using Lighthouse right now, yeah, go ahead.
Are there any of these things that are kind of mutually exclusive from each other, or
Yeah, totally.
Things that shouldn't be used in conjunction?
Absolutely.
Yeah.
Don't use any of these together. No, I'm just kidding. That's a joke. Code splitting and server-side rendering, for example, is a difficult thing to accomplish. It's not impossible. But I kept referring to this word hydration, which I just roll my eyes at every time I say it. It involves hydration strategies that get ever more complex the more you work on this, right? So these aren't just it's exponentially more complicated the more of these techniques you introduce with each other. So you need to understand what am I optimizing for and then chasing that goal, right? And just taking one piece at a time. But the first thing you're gonna do is optimize your images, right? So just make sure you're doing that. But yeah, all these things sometimes can work against each other. So be careful what you wish for and what you do. Google Lighthouse, definitely a tool that you should all be investigating your websites with. I think I actually have one open here for the LinkedIn feed, which I do not work on. So do not give me shit for it. But performance is a 7. That's depressing. So, okay. So you can, yeah, that's because we have Jennison that works there, right? Jennison's the man. So PWA, if that's what you're chasing, then pay attention to that number. That's not something that necessarily that LinkedIn is chasing at this particular moment in time. This 7, though, is enough to get the whole team fired, in my opinion, myself included. That first meaningful point, paint, 17 seconds, right? Like that's, I'm not going to say it. Well, you understand, maybe by the pained looks in my eyes. Sure. Ready, go. No, I'm just kidding. But what I really like about this is it says like, hey, look, if you can just figure out your render blocking style sheets, guess what? You get 3.5 seconds of performance for free, right? Well, for free, but you get it, right? Same thing here with render blocking scripts. I was referring to our shameful that we were not compressing text stuff. I found it here because it checks all that kind of stuff, enable text compression, all that kind of stuff. So it's an extension. It's something you can run in CI. They have a NPM module that will do that for you. And there's an application called Caliber that will actually run it to you as a cloud service that we're now using at LinkedIn, and again, has caught stuff for us already. So I would highly, highly suggest Lighthouse. It's just like right here. It's again, a Chrome extension. All right, let's go back to this. Be responsible. Many of you that did not come from CS backgrounds, I dropped out of college, so I'm not much better. But most of us did not get ethics class. But there are ethics involved in things like web performance. Like people that visit your site have a certain amount of trust in you. And like you're not just thinking about assholes like me on my fucking, my effing iPhone. I feel like there's like a level there that I had not yet crossed, and I just crossed it. Shit. Yeah, thank you. On your effing iPhones, right, in the middle of San Francisco on your LTE, and then you walk into your gigabit, right, and it loads websites that are 30 megabytes in second, or like a second, right? That's not everyone. You have people that are in rural India that are trying to like make connections on a job site that are spending literally non-trivial percentages of their income on their data to try and achieve this, right? And it's unethical for us to not think about that, right? So that's why I like don't waste time, don't waste data, and don't waste battery, because these are 3 things that may not be important to you at this moment in time, but then when you cross into some other country, it's going to be important to you because maybe it's your last bar of data and you just send a Facebook message to someone right before your phone goes off. Stuff like that, right? It may temporarily apply to you, and then it always applies to other people. So just think about the ethics of what you're doing. So thank you for listening to me. This was very cathartic for me. And I will happily come back to SAC again, so thank you.